Hello NSA student, this is Mr. Hinton with the Math Department. This is one of our frequently asked questions I get in the course. It says find the area of the regular polygon, give the answer to the nearest tenth, and what we're trying to find is the area of a pentagon with a side of 9 feet. So the most important part of this is to draw a picture of what is being described. So we want to take a moment to sketch this, and I did this already poorly. It's difficult to draw a regular polygon, but each side of this polygon is 9, and this is where a lot of students get confused. What is being given here? A lot of students will try to use that this is the radius because a lot of the problems that we've done use the radius. So we can use the formula in this instance. Area equals 1/2 the apothem times the perimeter. And we know the perimeter of this polygon is 45 because we have 5 sides that are each 9 feet. So 45 feet is our perimeter. That just requires us to find the apothem. Now recall that the apothem is the distance from the center of the polygon to one of the sides. So the way we're going to do this is we're going to draw this triangle here, and then we're going to give ourselves a little bit of room. I'm going to explode this triangle I just drew in red, make it a little larger so we can work with it. And this value right here is the value that we're trying to find. This side is 9, which means each of these little segments is 4.5. So that's 4.5, and that's 4.5. And now we're solving a triangle to try to find this apothem of this polygon. Now it's going to be helpful at this point to note that if we drew all the radii of this pentagon, okay, if we drew all the radii, we have 5 triangles formed, and 360 divided by 5 is 72 degrees. So each of these triangles has a 72-degree angle there. Which means that this angle in this triangle is 72, but there's 2 of them there with the apothem, so that's 36 degrees. Okay, so we have a 36-degree angle that we are working with, and if I wanted to, I could go ahead and now know that this one down at the bottom is 90 minus 36, which is, what, 54 degrees. I don't really need that, but if you wanted to use that angle instead of the top angle, you could. Now, at this point, I have a right triangle, and I can just kind of clean this thing up a little bit because we don't really need both sides of this triangle to find the apothem. So I want you to be able to just see the one right triangle that we're dealing with there. And I'm given an angle, the adjacent leg and the opposite leg, so I'm going to use the tangent function. The tangent of 36 degrees is equal to the opposite side over the adjacent side. Then we're going to cross multiply and divide by tangent of 36 degrees, and what we're going to get is A equals 4.5 divided by the tangent of 36 degrees. And that value is 4.5 divided by the tangent of 36. It's going to give us about 6.19. So our apothem is approximately 6.19. Now again, I'm going to keep more than one decimal place. The answer says to give it to the nearest tenth, but during the problem we want to keep more decimal places and then round our answer at the end. So from that point we can take our apothem value, our original formula looking for here. The area of this pentagon is equal to 1/2 times 6.19 times the perimeter, which is 45 times 0.5, and that gives me an area of 139.4 feet squared. Thanks and have a great day.